establishing basic trigonometric identities. We use the following formulas. Reciprocal identities: cosecant is 1 over sine, same angle. Secant is 1 over cosine. Cotangent is 1 over tangent. And quotient identities: tangent is the ratio of sine and cosine, and cotangent is cosine over sine. And we have even odd properties. Sine and tangent are odd functions, so sine of negative x is negative sine x, tangent of negative x is negative tangent x, while cosine is an even function. That means cosine of negative x is just cosine x. And the most important Pythagorean identities here: sine squared plus cosine squared is 1, tangent squared plus 1 is secant squared, 1 plus cotangent square is cosecant square. And cofunctions: sine 90 degree minus theta is cosine theta, or the same angle x. Cosine of 90 minus theta is sine theta. Tangent of 90 minus theta is cotangent theta, or just x. Okay, cofunctions. Now, when we establish identities, let's say the following example. Let me write one example here. Establish the identity. So we have cotangent theta over cosecant theta equals cosine theta. This is the left hand side, and the right hand side. Always work from the more complicated side. Sometimes that could be the right hand side. Okay, work with the more complicated side, and you cannot add or subtract from both sides. Okay, you cannot manipulate both sides. You can work one side and other side independently, but you cannot move terms around. So in this case, I'm gonna start with the left hand side. Left hand side, in short, LHS. Left hand side is, let me rewrite, cotangent over cosecant theta. And if it is possible, always simplify, writing in terms of sine and cosine. If we go back here, look at here, cotangent is 1 over tangent, but that's not nice because we want to always go for sine and cosine. Cotangent is cosine over sine, so here cotangent is cosine over sine. And cosecant is 1 over sine. Now we got a complex fraction, and we can simplify this. Keep, change, flip. The top is cosine theta over sine theta times sine theta over 1. Now we can cancel the common factors. That leaves cosine theta over 1, which is just cosine theta. And that is what we are supposed to get. That's the right hand side. Let's do another example, number 2. Secant theta minus secant theta times sine square theta equals cosine theta. Again, the left hand side is more complicated, so let me write left hand side. Secant theta minus secant theta times sine square theta. Here we got two terms. Okay, and whenever we have two terms, try to combine. In this case, we can factor something out and combine. If we have fractions, then we need to add or subtract. So in this case, secant theta, I can factor secant theta out. Nothing left means 1 minus sine square theta. Now 1 minus sine squared. Let's go up and look at this Pythagorean identity. As we know, sine squared plus cosine squared, same angle, equals 1. And we got 1 minus sine squared. From here, we can subtract sine squared both sides. So we get cosine square theta equals 1 minus sine square theta. So 1 minus sine square theta is same as cosine square theta. So here secant theta times, because we are trying to simplify out of these two terms. Now 1 minus sine square is cosine square. We can write cosine square theta. Okay. Look at the right hand side. We are supposed to get cosine theta. Just keep in that mind. So when you manipulate, try to leave cosine. Okay, don't change cosine because we have to get cosine at some point. Now we got secant. What is secant, by the way? Secant is reciprocal of cosine. So this is same as 1 over cosine times cosine square theta. Now cosine square, that's on the top, this cosine on the bottom. So one copy from top and bottom can be cancelled. That leaves cosine theta. And that is what we are supposed to find. That's right hand side. Look at more examples below.